The backward pass is very similar to the forward pass in that it follows the steps of the project, but it uses the late finish and late start to calculate the critical path. The lower portion of each box empty. Now we're going to use those to work backwards from the finish to determine the critical path. Starting on the right side of our diagram with the finish box, we see the total projected time to be 110 minutes. Just like the forward pass, we will use these numbers to calculate time, but instead of adding time to each box, we will be subtracting time. To begin, we take the late finish total of 110 in H and subtract the duration and put that total in the late start location in H. And since the duration in H is 0, the number remains 110. Now, take the 110 from H and move it to the late finish of G. We subtract the duration of 10 from box G and it gives us a late start of 100 minutes. Since we now have a split and we don't have any competing elements, we transfer the 100 to both late finish spots in both F and D. And at this point, we can complete one branch or the other, so we'll stay with the top one. Taking the late finish in F of 100 and subtracting the duration of 40, we now have a late start of 60. You may start to see a pattern here where the numbers are matching. Taking the 60 and putting it in the late finish of E and subtracting 30, we now get a late start of 30. We take the 30 and put it into the late finish of C, subtract the duration of 30, and it leaves a late start of 0. We're going to stop here because we don't know whether or not to use this number or the one from below. So now we're going to finish the lower branch. We now move to the activity D, and the late finish was D, which we had transferred earlier, of 100. So if we subtract the duration, 15, we get 85 as the late start. Now we move the late start of D into the late finish of B, subtract the duration of 5, and we get a late start of 80. And since we always use the smaller of the two numbers on a backwards pass, the opposite of the forward pass, we transfer the 0 from activity C into activity A, the A slide. And since 0 minus 0 equals 0, they match. Now looking at the two branches, we see that the upper branch, the early finishes and the late finishes are exactly the same. But looking at the bottom branch, they're different. This shows us that the critical path is once again A, C, E, F, G, and H because the early finishes and late finishes are equal in each of those activity boxes. If we delay any of these activities by any amount of time, the project will not end on time. So as a recap, starting from the finish, we take the late finish of each task, subtract the duration, and move the value into the late start. Transfer it into the late finish of the next task all the way through the project. The only time you have an issue is when you get to the end. And since we're now looking for the shortest time in the backward pass, we choose the 0. And if it's not a 0, whatever the lowest number is from the top row. We just happen to use a 0 in the top row. Now that you can see that the early finish and late finish are the same across the top, you confirm your critical path. Any changes in time to activities in that branch will delay the project. So now let's look at how to calculate total slack and free slack, which we'll cover in our next lesson.